In this recording, we're going to learn how to do some challenging factoring. In this recording, we're going to learn a very cool factoring technique. You have learned how to factor trinomials when they have a greatest common factor, or when the a value, meaning the coefficient of the x squared, is a 1. Normally we don't have a number written there. But as you can see on the examples on this page, there is an a value, a coefficient of the x squared, that is not a 1. So that adds a level of complexity to it. So I'm going to teach you a technique that's going to work here. So first off, we're going to first look for a greatest common factor. Nope, don't have one. We're going to proceed to set up our window, our 2x2 grid. Okay, now let's see, we've got 2x squared like before, and 6, the constant. We can put those in place. Here's the dilemma. We've got our x and our 2x, because those are the factors of 2x squared. Now, the numbers that go here, this is where it gets a little more complicated. The numbers that go here are not necessarily factors of 6, because they also need to be factors of 2. So I need to actually look for numbers that are factors of 2 times 6. Okay? 2 times 6. So when I come over here and make my list, it's of 12. Okay? 2 times 6. So I'm looking for factor pairs. So I've got all my factor pairs of 12. Keep in mind, it's not simply 6. It's A times C. All right, so what I have to find is the pair that adds up to negative 13, that B value. So hopefully you spotted it. It's that one right there. Okay, again, when I put that in here, negative x, negative 1x, negative 12x, the positioning of these two x terms is important though. You might wonder, well, can I just place them in either window pane? Does it matter? It does, actually. If I were to put the negative 1x in this pane, 2x can't multiply by something to make negative 1x, so it wouldn't work. So I have to have it oriented like I have it. So 2x times what makes negative 12x? And hopefully you recognize that's a negative 6. And then x times what makes negative 1x? Well, that'd be a negative 1. Okay, so let's check our factorization. Does it all work out? Negative 6 times negative 1. Yes, I believe it does. So we have our factorization here. X minus 6, 2x minus 1. Okay, we're going to try 2 other ones in this recording. Okay. We're going to skip right now. Let's skip number 1 and 2, and let's dive into number 3, because that's a little more challenging. So on number 3, okay, so we're going to place our 3x squared in the top left and our negative 12 in the bottom right. We don't yet know what numbers are going to go there, but we do know that they're going to add up to, pause the recording and see if you can put down here what they need to add up to. I think you know this. Yes, they need to add up to negative 16x, right? Just like our previous one, they added up on the diagonal, the like terms, to negative 13x, the middle term, the B term. Okay, so what we've got here is we're going to multiply 3 times negative 12 to be negative 36, right? So we need to start making a list of pairs that multiply to be negative 36. Okay, so remember we have this technique. If you have a graphing calculator, and I know you often don't have it at home, but here's how we're going to do it. If we have it in class, we're going to do negative 36 divided by x. And then we're going to look in our table. Okay, we're looking for number pairs these all multiply to be negative 36, right? 2 times negative 18, 3 times negative 12. But what I'm looking for are pairs that add up to be negative 16. So just mentally, wait a second, did we just get lucky and nail that on the first try, right? 2 plus negative 18. It worked out for us. Sometimes it's better to be lucky than good, right? So all these other ones multiply to be negative 36, but they don't add up to be negative 16. All right, so cool. So we found 2 and negative 18. Let's put those in boxes. We have to be judicious where we're going to place these numbers. Let's see. 2x and negative 18x. Okay, and because I haven't placed anything up top, I can place them in either position. It's actually the better way to do it. I should have done that from the previous one. Now on the edges, I'm going to find the greatest common factor of each row and column. So up top, GCF of 3x squared and 2x. Well, it's just going to be x, right? And on the side, GCF of those two terms. Let's see, it's got a 3 that goes into both of them, and it has an x that goes into both of them. And now coming across here, what's our GCF of these? Well, it looks like a 2. And then finally, over here, what times 3x is going to make negative 18x? And it's going to be a negative 6. So there's my factorization. 3x plus 2, x minus 6. The last example I'd like to do is number 5 on the following page. I'd like you to get as far as you possibly can with this. I want you to pause this recording, get as far as you possibly can, play the recording when you'd like some help. Okay. Look for GCF. Don't have one. A value is not 1. So let's set up our box. Okay, now in terms of your list, 6 times 12 is 72. So I need a list for 72. Go to my calculator. I do 72 divided by x. I look at my table. Okay, so I have lots of number pairs that multiply to be 72. Now I should be asking myself, do I need to think about any negatives? Nope, there's no negatives in here. So it should be all positive pairs, and they need to add up to 17. So as I scan down here, I'm looking for numbers that add up to 17. Bingo! 8 and 9, right? So 8 and 9 are my pairs. Okay, again, if you got this far on your own, keep working on it. If you didn't get this far and I helped you get this far, get as far as you can now by putting your factors on the edges. Play the recording when you're ready. Okay, so hopefully you paused and did as much as you could. I'm looking for greatest common factors. So I see here in the top row a 2x. And then in this first column, I see a 3x. Good, that'll make a 6x squared. Now going across, 2x times what makes 8x? It's got to be a 4, right? 3x times what is 9x? Well, it's got to be a 3. So now I have my factorization. And again, these factors, because we're multiplying, the commutative law of multiplication, can be written in either order. Thanks for watching.